HPC Toolkit is an integrated suite of tools for measurement and analysis of program performance on computers ranging from multi-core desktop systems to large supercomputers. HPC Toolkit uses statistical sampling of timers and hardware performance counters to collect performance measurements and attributes them back to full calling context. Since HPC Toolkit uses sampling, measurement has very low overhead and scales very well with parallel systems. The workflow to use HPC Toolkit is as follows. For dynamically linked executables, there is no additional step required at compile time to use HPC Toolkit. Code can be compiled with all optimizations enabled. "-G option should be used to include line numbers in the binary. The DRTM implementation under consideration is a dynamically linked executable. HPC Toolkit provides a utility called HPC Run to collect performance data. Measurement of execution characteristics using HPC Run is unobtrusive. It has very low overhead and hence keeps execution behavior of the program intact. HPC Run can be used with DRTM as follows. DRTM is executed using MPR runtime with 16 processes and each process containing 8 threads. Performance data is collected using real-time timer sampled at 1000 milliseconds intervals, followed by specifying DRTM executable and its input configuration file. Instead of real-time timer, other events such as cache miss, CPU cycle, etc. can also be used. HPC Run attributes the measurements back to calling context. Measurement is taken when the timer or hardware counter overflows. The full call path up to main is gathered using stack unwinding. The call paths are combined to form the calling context tree. The calling context tree for Lulesh application is shown. To recover program structure from binary, HPC Toolkit provides another utility called HPC struct. It maps different parts of the binary back to source code. HPC struct can identify structures such as nested loop, inline procedures, and so on. The structure of DRTM binary is extracted and stored in drtm_mpi.hpc struct. To combine program structure with the performance data collected, HPC Toolkit provides a utility called HPCProf. HPCProf is capable of combining profiles of multiple threads, multiple processes, and so on. HPCProf takes the structure of the program extracted using HPC struct and measurements taken using HPC Run and combine them to create a performance data database. HPC Toolkit helps to visualize the collected performance data from different perspectives. HPC Viewer gives a code-centric view of the performance data, and HPC Trace Viewer gives a time-centric view of the performance data. Since we cannot show the source code of DRTM, we present details of HPC Viewer using LLNL's Lulesh application written using Taja framework. HPC Viewer has a source pane that shows the source code. Navigation pane helps to move up and down the call chain. Metric pane shows the performance data associated with the source lines. HPC Viewer also allows to choose between top-down view of the calling context, which starts with the main, and also bottom-up view, which starts from different functions tracing back to main. In the navigation pane, we can see that HPC Viewer can associate inline calls and loops back to calling context.